Hello 1324 students. One of the advantages of having a face-to-face class is that first few days I get to show the students some tricks to make the class a lot easier for them, involving using this graphing calculator, which, as you saw from the syllabus, is required in my class. Remember, I ask questions assuming you have something like this to use during your quizzes or tests. So my questions are harder. They're not just, calculate something. They're using the mathematics to try to understand how to do applications. So I need you to have one of these. And let me show you a couple of things I would normally show a face-to-face class, ways to make this work really efficiently for you. All right. So section 1.2, already you have questions where you're asked to look at a polynomial model of the earnings of a company. Here it's Starbucks net earnings in year X, where X equal to 7 corresponds to 2007. So you have to figure out what's going on there, right? X equal to 0 would correspond to year 2000, and so on. 2020 would be X equal to, right, so you should be able to answer that. Okay, so this polynomial supposedly models their net earnings in each year, and the output is coming in millions of dollars, okay? So in this problem, section 1.2, already you need to evaluate and or graph this polynomial, okay? So let me show you how, in this video, I'm going to show you how to evaluate and graph, get that picked off with one set of moves. And in the next video, we're going to talk about how to find the zeros or mins or maxes of functions in a similar way, okay? So in that question, section 1.2, or in those questions, problems 41 through 48, they ask you a bunch of questions, which essentially boil down to this. Find the approximated earnings, the earnings approximated by this model for all the years from 7 to 16, and compare them with the bar graph, which represents data actually acquired, recorded net earnings for those years. And that was probably used to make this model. So to use this polynomial to model that situation and answer questions in those problems, 41 through 48, you need to do the following. So you need to get that function into this calculator. And if you are somebody who's used to doing that, well, then you don't have to worry about this the rest of this video. But if you are somebody who's brand new to this idea, then you need to know your way around the calculator. And so if you go to y equals, and I know you can't see that screen, and let me bring it really close, okay? I entered that polynomial in here. Now that's all fine to say, but what students have a lot of difficulty with dealing with are some eccentricities of the graphing calculator, this TI 83, 84, 86. Casio's the same thing. This is just a small computer, right, that you're allowed to have on a quiz or a test. And so it has some weaknesses. One of them is that if you just write this 4.79x and then the 3, it's not going to know, like you and I know, that the 4.79 gets multiplied by the result of x being cubed, okay? Calculators, computers are not that smart. So in some instances, this has been programmed to be that smart, but in others not. So best practice is to always assume the calculator is this dumb and that you have to write out 4.79 times, right? So when you press times here in the calculator, it shows up as an asterisk in the lovely screen here with the beautiful graphics. Okay, so you have to write times x raised to the third. I often have students who don't know about the raise to the button. There is the exponent button, raise to the right there, okay? And minus 122.5 times x and times here, okay? So every single time you're using, sorry, pun, every single time you're doing this throughout the course, remember to use the multiplication. Why? Because if you don't remember it, it sometimes doesn't do it and you get wrong answers. Flip that around. So if during this course you're getting wrong answers out of the calculator, go back and look at how you typed it in. Did you always replace every multiplication or implied multiplication by using a multiplication symbol exactly? Okay, so that's one of the things I always have to tell my 1324 students. All right. Now, the other thing is we are trying to reproduce in our calculator a graph that resembles that table on page 17, okay? And also we are trying to read the fine print here. It says, this is a good model for Starbucks net earnings, but only for the years for X going from 7 to X to 16. In other words, from 2007 to 2016. We can't type in X equal to 20 and get a good approximation for their net earnings this year. So this model only claims to work in those years. So we need to set window. Here's window. Now you don't always need to set window. Sometimes you can get away with zooming in, zooming out. Yes, that's true. But to see exactly what everybody else is seeing, you can be accurate and go to window. When you press window, it asks you, what do you want x min to be? All right, so the calculator, so you've got a graph, you've got, here's all the x's, here's all the y's out there. Your calculator window, last time you used it, might have been set to be up here, where this boundary is x min, this boundary is x max, this one across the top is y max, and this one down here across the bottom is the y min. So when you change these numbers, you change where the eye of your calculator is looking in the plane. Okay? So if you want to see a picture like the one of the graphic in the book, and also follow the fine print, the rules say that this only holds from 7 to 16. Well, you want to see those x values of 7 and 16 in the graph. So I recommend you send x min, the boundary, as a little bit to the left of that, 6, or x max a little bit to the right of it, 17, a little bit to the right of 16. In that table on page 17, the bottom of the window was y equal to 0. And the top of the window, they had 3,000, but when I graphed it, it didn't look exactly like that. So I had to change that to 4,000, a little bit higher. You're changing the boundaries of your frame so that what you see inside represents everything you need to see mathematically. Okay, so students often say, wow, where'd you get those numbers? By reading really carefully and having done this a number of times. So that's why I'm doing the video, to give you some of that expertise. But reading the problem carefully and thinking about what the input represents, time in years since 2000, what the output represents, that can often help you get through how to set the parameters on the window to be able to see the graph. And you'll learn how to do this better and better as we go along. Anyway, so you press second function quit and you get out of window, and then you can hit graph. I'm trying to make sure that you guys see this and not a bunch of glare. So you can hit graph. Looks like we're pretty good. Let me just lower this a little bit. Okay. All right, so you can hit graph, and then you will see something that is about the same picture that they're looking at in that table on page 17. After you've entered it in y equals, you can go to table set, which is second function table set right here, and ask it to produce a table starting with your table start value. So if I put in 7, because that's when the model became is accurate, and the change in table is just set equal to 1. I get the lighting right there for you guys. Then you can, once you got that in there, just press second function quit and go to second function table. And so there it starts off. Well, I've tried to reproduce it here. For x values 7, 8 on to 16. The value of y1 is the value of this polynomial, and so you can use these numbers to answer those questions about those years. Okay. A third thing that you could do, and might be asked to do more of later or in 1325, is to use this polynomial model here to get some data on what happens in some year X that maybe you can't see on a chart. So same sort of thing, being able to evaluate the function, doing a bunch of evaluations all at once is very handy here. Or you can also use a thing called trace. Let's see now, where is trace? Ah, there we go, trace, right there. So if I go back to the graph, so here's my calculator doing that graph, right? And when you see a bunch of dots over there on the upper right-hand side, that means it's still graphing. So no point in punching buttons at that point. You gotta wait for it to finish graphing. You can hit trace and it will give you a particular point on the graph. So right now it's saying x is equal to 12, y is equal to 1022.12. Let me write that down. So let's say right here, that's where I've got trace. Has taken me to this point. It's implying that this ordered pair, this point on the graph, has coordinates. Writing them down again. Let's see, that's 12, comma, 1022.12. A skill that's good to have in this class is to be able to look at a point on the graph and analyze that, say what is going on there. So if x is equal to 12, that means we're talking about year 2012, right? What's happening in year 2012? Well, the y values, which measure net earnings in millions of dollars, are 1022.12. So from every data point on a graph, you should be able to write a sentence explaining what's going on, right? So in 2012, just from that one data point, can you guys see what I'm writing there? There we go. In 2012, Starbucks net earnings were approximately, now you don't want to write just 1022.12, right? This is in millions of dollars. So do a little scratch work on the side. 1022.112 times 10 to the 6, which is a million, is the same thing as, let's see, if I write that as 1.02 times 10 to the, what is that now? Let's see, for this to equal, that's a times, not our x, by the way, 1.02 to equal this, I would have to move this decimal place over 1, 2, 3, 3 places. So 10 to the 3 more than this, 10 to the 9. Well, what's that? 10 to the 6 is million, 10 to the 9 is billion. So you could say, or approximately, $1.02 billion. Okay, so that is the type of thing we want you to be able to do, interpreting a graph using the units, using scientific notation, and being able to do so means that other people in an application who can't understand how to analyze the graph will always turn to you. Okay? Practice that.